Hey, my name is Mahan, I'm the CMO of Naron.
My name is Luca, and I'm the CEO of Naron.
Luca, in a previous video, we covered RAG. But what most people don't know about is a big component of what makes RAG work is a vector database. So in this video, let's break it down and let's give people an introduction into what a vector database is.
For sure. So quick refresher on RAG is essentially a very good librarian that can go through a very big library and pick out the best books or documents in our case to best facilitate the AI agents to be able to give you the best answers. Now, every librarian needs a library. In this case, the vector databases are the library itself.
Okay, to start, let's make a distinction between a regular database and a vector database.
Yeah. A regular database is very structured. So it has different columns, for example, price, and then it has different rows for example, products. And so when you look at a product and you want to find the price, you just go down the columns and you find the price. Pretty simple. A lot of people are familiar with how regular databases work. Whereas a vector database, it's actually a very flexible database that is actually built to store all of the meaning and all of the context in the world. So everything from numbers to physical objects to places in the world, everything can be stored in a vector database and traversed through a RAG. So one of the big differentiations between a regular database and a vector database is a regular database is typically just two-dimensional, as I just mentioned, rows and columns. Whereas a vector database can have up to like 4,000 or 5,000 dimensions that you can traverse. And vector databases are typically notated in arrays. Arrays are essentially just a series of numbers. So as you can see here, they're like coordinates. They're very small coordinates, but there's like 4,000 of them in one go, essentially. And it signifies one meaning. And so you could think about it this way. If you had 4 or 5 different objects, one of them was a dog, one of them was a cat, one of them was a leaf, and one of them was a squirrel. Essentially, the squirrel, dog, and cat would be very close in the vector database, whereas a leaf would be pretty far away. And so the LLMs are able to actually identify and do math to see how far certain data points are from one another. And that's actually how it derives a lot of the meaning.
Vector database is like a regular database has an input side and an output side. So what does the input side look like on a vector database?
So the inputs on the vector database are anything like documents or chunks of text, or even a sentence or two. And so those documents, those images, they go in through a little model called an embedding model that takes the tokens and actually spits out what their coordinates are for all of those 4,000 dimensions. And so whenever you put something into the vector database, it kind of goes through this little model. And then whenever you want to retrieve it, you kind of do the opposite. You essentially ask a question. The question is then put into the vector database, and then it finds which are the closest data points to that question.
That's all very abstract. What does it actually look like in a real world scenario?
So let's say you have an AI agent that's responsible for Stripe and billing. Essentially, what the AI agent will do if you ask it a simple question like who canceled last month is it will take information like renewed plan, canceled plan, and voided purchase, and it'll categorize them differently because of the context is different. So if you actually look over here, renewed plan, even though it has the word plan, is very different from canceled plan. And whilst canceled plan and voided purchase textually don't have anything similar, contextually they do. The AI agent will be able to identify that you are now looking for canceled plans and any data points that alert to a plan getting canceled or a purchase is voided will come up in the RAG search for this case. Okay,
and let's conclude it with a real world scenario of how you'd apply a vector database into a RAG system for an actual business then.
Yeah, so we actually do this a lot on our day-to-day. We build these AI agents that use RAG to look at different stuff like support tickets, internal docs, and sometimes these support tickets work with and alongside the docs, sometimes separately. We look at product specs for the agent to understand what exactly is it selling or what exactly is it providing customer service for, and past contracts. So if there's anything that we need to kind of go back and get some more customer information on, the past contracts will provide that information for the LLM. Now, the really cool thing is that this very much becomes essentially this memory layer at the company level. So think about it this way. All your company meetings, all your sales calls, all your internal meetings can be stored in a vector database and then traversed contextually. Let's say, for example, you ask a simple question like, hey, what did I promise the prospect on last week's call? They'll be able to traverse not the entire transcript. We don't want to overbloat it with all of these other details, but it'll go towards the end of the call because, by the way, time is one of the dimensions that it looks at. And then it'll be able to actually pick up on that. A really cool thing, and this is a little bonus, is that because time is a very big dimension inside vector databases, the information automatically adapts and updates itself. You don't have to delete information from the vector database. This was the problem that we thought we would have when vector databases came out. But we actually figured out that if you search for the latest update on a client, it's able to do that because it understands time. And so it won't give you an update that was done 3 months ago.
We've done a concise breakdown of RAG so far, but of course it's a very complex concept when it comes to AI. So we'll dive deeper into it in a future video. Until then, guys, subscribe to our newsletter, links down in the description below. You can also find us on LinkedIn, where we're very active on a day-to-day basis. And until then, we'll see you in the next video.